do this. And then just to confirm, I did get permission from Dr. Pillai to use the review sheets that I got when I was taking her class, to be able to start going over, like doing review, kind of similar to how Dr. Pillai was doing with you guys. So I will start that. I will start that next Wednesday. So Sunday, I'm still going to hold normal office hours like I normally do. If for those of you that have been coming, you guys know what that looks like. But and then yeah, so then I'll do like the review on Wednesdays. I won't get to release them to you guys, I don't think, but I'll at least be able to like go over them with you. So anyway, just update you guys on that. So so yes, let me see, this is alcohol. Yeah, so you guys are doing alcohols, and then you're doing a little bit of this. Here's retrosynthesis. Okay, yes, this part, right? This is where you guys are at. Okay, how are you guys feeling about this stuff? Talk to me.
Can I just ask my question really quick before we get?
Yes, you got. Okay,
cool. So with the next one for alcohols, I was a little further down on this.
Here's alcohols. Yep.
Past nomenclature.
Acidity.
With the acidity. Yeah. Okay. So for this one specifically, go down a little bit more. For where there's like the line ones. For some reason in my head, I thought that like
the electron withdrawing groups, is that what you're talking about?
I guess any of them with the Renaissance contributors, for some reason in my head, I thought that like you could just go around the circle forever and just keep moving it from like a bond to the like little where it touches each other to another double bond. To a carbon and go around, or like on the lines keep going around. So I'm like confused because in the examples, it doesn't show it like that. Like there's only like 2 red sauce contributors for like some of them, but like when I was drawing them, it was like, this is a line, so why can't you just keep going?
Yes, because remember, you only have resonance contributors. You can only move electrons to up to an sp2 hybridized. You cannot add on sp3. So if you have something like, say, let me see, these are all the original one here. These are all sp2 hybridized, but let me see if I can find an example. These ones. Okay, let me just try to make one up. Let me see. So we have, let's say you have this here and this here, right? And you have a pair of electrons that you want to dump down on here. Let me actually draw this on the other side. 1, 2, 3, 4. Okay. Okay, so if we were to dump our electrons here, these would go here, and then you would have double bond to your, and then you would have these here with this here, and then these could go here, and then these electrons could come over here, and then you would have, obviously I'm not drawing my electrons
here. Yeah, so you could go all the way around the circle then, right?
No, I'm about to show you. So then these would go here, and these would go here, and that's it. As far as you can go, because this is sp3 hybridized. Remember, we have some implied hydrogens, right? And you can't dump your electrons, like carbon can only have 4 electron domains, right? And so a double bond obviously counts as 2. You have electrons in your sigma and your pi orbitals.
Okay.
So with this one, I always tell people, if you are not, it's okay to draw in your hydrogen if you're not positive, and just check. So that's why I was counting 1, 2, 3, 4, right? Because I wanted to see There's there's a carbon right here, right? So here's 1, 2, 3. So that means I have a hydrogen here. But because it is 1, 2, 3 electron domains, that makes it an sp2
Yeah,
hybridized carbon, right? Yeah. So that's why I can't dump it over here. I can't dump it over here because this carbon already has 1, 2, 3, 4, all of its electron domains already filled.
Okay, so for the line ones, then it's like the same thing when they have like
Mhm.
wherever the double bonds are. Okay, that makes sense.
Yeah,
Thank you. I was just like getting
Now
very
add
confused.
your hydrogen. Just double check that you know what your hybridization is on the carbon.
Okay, and then the one other question that I had that was not really necessarily, I guess, homework related, but you put in your announcement that we had to do 600 problems, but her syllabus said 750. Did that change back to 600? Because I know
No,
there was
probably
some.
not. That was how much it was when I was doing it. Follow
Oh
whatever
yeah,
her
that's what it was
syllabus.
before too.
Okay, cool. Yeah, I apologize. I just assumed that it was the same, but then, you know, that means even more, right? So however much that comes out to. So I'm just
I
saying
was just
that.
hoping that
So
like maybe she changed it and we just missed it.
no. So 750 divided by 6 is 125 a week, divided by 7, that's 17.9. So essentially 18 problems a day minimum just to get the credit, right? I would say do twice that to make sure you understand concepts. But, you know, if you're understanding it, then move on, do something else, you know, and just save some problems and go back to it. Just to remind yourself, right? Because the best way that you're going to learn is to like keep going back to it and keep practicing it. But yes, thank you for clarifying that, and I apologize, and I will update. I'll just make a quick announcement update so that way people don't take my word for it.
Okay.
Yeah. Yes. So yeah, you're funny. I just heard your comment. Yeah, Dr. Ply is amazing. Is it L or Ellie or LA or I don't know if you're still here, but I saw that you asked if you could ask a question. I don't know if you already did, but please feel free at any time. Yeah, so you know, how's everybody feeling about I mean, I guess I'll just kind of go back to like, you know, your reactions, your mechanisms, your with this one, retrosynthesis, synthons. How are y'all feeling with those? Thumbs up, thumbs down. I can't see a bunch of you because I am doing a screen share, so it's just, you know, you could either
Can
comment.
we do a retrosynthesis including like epoxides?
Yeah, like something like this, you mean?
Yeah.
Like how
And
that
like
says
how,
an epoxide in it?
yeah,
I
like how
know.
that function would open up.
Yes. Yes. You mean like let me see, are these retrosynthesis? Oh yeah, they are. Okay. So remember that your in this one we're specifically using the acetylide anions. So what happens is you have, when you're looking at this right here, let me just change my colors. Okay, you have to be able to hit you've got a carbon here, a carbon here, a carbon here, right? And I know especially with the epoxides it can be a little confusing because it's like it's all the lines and it's like this little tiny, you know, triangular thing, and so you're like, where is it going to go, right? And so you're not going to do an SN2 reaction because this is that's sp3, it's a tertiary. So and SN2 is not going to happen on I'm sorry, on this one right here. SN2 is not going to happen on a tertiary carbon, if you remember. So it has to happen on like at the most a secondary, right? And so that's why you're going to choose, you would choose for it to go onto this one over here. And so and you also want to think about like with these, you have to remember that you have this you have this delta negative is partial because we have these differences in electronegativity. And so you have your delta negative there, and then so your delta positive is going to be on these. And so that's why you have to choose kind of one of these two. It has to be one of the carbons that's connected to that oxygen, as opposed to like maybe say this one over here, because you're not going to have the same, first of all, that, you know, whatever, you're not going to have the same ability to break those bonds. So you'll come onto this green. I'll just do this one a little bit lighter green. You'll come onto this lighter green one here. And then what happens is these electrons from this get dumped onto your oxygen because we don't need electrons. We already have these two right here, right? So what ends up happening is then you have, so count your carbons, right? This is something I cannot emphasize enough. Count your carbons, count your carbons, count your carbons. So we have 1, 2, 3. It's not a good color. Sorry, y'all, it's like blending in. 3, 4, 5 carbons, right? So I lost many a carbon in my in my time. So we have 1, 2 from the original. So here's 1, 2. And then we have 3, 4, 5, and it's all in a line. You see that? So if we just erased this bond right here, we have a line of carbons, and the oxygen is attached to the middle of those 3, right? And so that's why we have here, we have 3, 4, 5, with our oxygen attached with its 3 lone pairs to the middle carbon. And see, we already had 2 lone pairs here. And then the 3rd lone pair came from breaking this bond where the orange X is. And then once you're here, because you're water everywhere, right? But it's you'll hydrate, take this hydrogen here, which will neutralize that, and then you end up with your alcohols right here. So I know with epoxides, like breaking it open and finding out exactly like where it would go can feel a little confusing. Definitely count your carbons. This is like a very simple example. Does that start to, like, what do you have for questions about this example so that I can help?
That was, yeah, it's starting to make sense for how it opens. My next question, I guess, building off of that would be, when we're doing retrosynthesis, how do we determine between like the group being in an epoxide and like an alkene? Does that make sense? Or an
Okay.
alkyne?
Yeah, so what do you mean by grouping? What do you mean by grouping? Just so
I don't remember saying grouping.
Oh gosh, why did I thought you said, I don't know. Okay, so can you repeat the question then?
Yeah, so for the homework in the synthesis using the Grignard reactions,
Yeah.
a lot of them contained where you break it into synthons, then you use the one synthon. Sometimes they were epoxides and sometimes they were alkenes, and I'm just asking, when do I know
Double
which
bonds, you mean?
Yeah, double bonds, which ones to use.
Okay. Let me get down to Grignard just so I can look to see if they have any examples. Because I haven't looked at the homework site for this yet. So like if for this, for example, this is with an epoxide.
Yeah, we can start with that and see if that answers anything.
Okay. As I'm looking to, and then this is with an ester. Let's see, I'm just trying to see if they have double bonds in here, but okay, so let me just start with this one anyway. So so your question in this would be, how do you know the difference between like if they've started with, okay, so with the Grignard, right? So we have this is like one of the only times when, or like limited times when, right, carbon's going to have this partial negative charge. And again, because we have this partial negative charge over here, we have two partial charges on this side, which is why we choose, and again, can't do SN2 on a tertiary. So that's why we choose this one. Count your carbons, right? So we know we have 6 here. This bond, these electrons here are being used because it's to create that new bond. So we have a carbon here plus our phenyl group. And then we have 1, 2, 3 carbons again with the epoxide on the middle. With the eventually alcohol, but oxygen in the middle. So we have, here's our carbon that we're using to bond from our phenyl group. And then we have 1, 2, and 3, right? And so what ends up happening, as you can see, right, is that this, your Grignard attaches to the oxygen. And so then we would have, yes, and then this is how you turn it into your alcohol, right? So you have your H3O, right? And we get our hydrogen from here. This is a good leaving group. It says see you later. And then from here, you're asking, how would you know to choose for this one? Let's say that this is a epoxide versus, I think maybe a good way to tell is like if you have an oxygen, right? Because if your options for a synthon in this case, right, would be if you wanted to say, you could use a bromine, I guess, right? But you've kind of got your bromine over here already. So, but what you're saying is, how do you know that it's not a double bond? What's it? 1, 2, 3, 1, 2, 3 with the oxygen. No, whoops. 1. I did too many. With the oxygen here, right? Versus like an actual epoxide.
Yeah.
That's what you mean? I would say that the best way to make that decision is it's going to in this case, right? And as far as for this, it's going to be more stable. What are your options? Your options are to put a bromine on here. It doesn't make as much sense to have, because you're not going to have a you need to have that partial bond. You need to have that delta, that change in your dipole moment, right? So that's what makes this possible for it to attach here, because you have that difference in dipole versus over here you don't have this carbon-carbon bond. You also have to remember now it also has 2 hydrogens, right? And so there's no dipole moment happening here. And so in order to create, we just don't have the magnesium bromide needs to have something to interact with. And so that delta, right, that the other way around, that dipole moment is what creates that, and you wouldn't get it off of an alkene in this instance. Does that make sense? Do you see the difference in the dipole moment would be here. You would have the negative here. Whoops, other way around. Yep. Jeez, I don't know why I do that. Right, so then you would be attaching here, which you're not, because you can't do an SN2 on an SP3. On a 3rd degree, on a tertiary carbon.
So for those synthons that they have created underneath, when it's turning into an epoxide, why couldn't we take an electron from the oxygen and create that double bond there?
You could, but there's a positive charge here. So you'd have most likely, I'm not saying it wouldn't happen, right, but you would most likely, the amount of times, remember that when we're doing these reactions, the biggest things that you want to think about is what is going to happen the fastest, AKA what's going to happen the most often, right? Because if it happens faster, you're going to have more of it, right? And so just like how you can have, if you have a second degree, a secondary carbon, you're going to have both SN2 and E2 reactions going on at one time. But if you have, depending on what your solution is, or what your Lewis base is, or whatever is, like, that will kind of depend on what you're going to see more of in that reaction. And so in this case, yes, of course, you could also have, you could also have these coming here. Where is it? Oh yeah, you could also have those coming here, and then you would make your double bond. But most likely, because these electrons are going to want to stabilize that carbon, because remember, having a cation on like a first degree cation is like extremely unstable, right? So you're not, that's why like we kind of talk about that stuff a lot in the past few chapters, like the last couple chapters in Chem 1, and then these first couple chapters here is like a reminder that like this is a very unstable cation. And so it's not going to stick around very long. That's why we have rearrangements in SM1 and E1, because the cation is going to want to find the most stable position. And because oxygen has these electrons that it's willing to interact with, it will end up interacting with that carbon.
Okay. Yeah, that makes a lot more sense.
Cool. Yeah. It's not necessarily that it wouldn't ever happen. It's just, it would probably happen so little that you would just never see it, basically.
Yeah.
I think the way to think about chemistry is like anything that that can happen will, but we want to know like what's going to happen the most, what's going to happen the fastest, right? Like pretty much anything's possible, but there's just things that just have such low probability of happening, you might as well consider them impossible, right?
Yeah. So would you say, like, is there like a way to like decide what the like synthon resonance structure is gonna do? Or
Yeah, so like in this case, for example, if we're choosing to have this synthon here, right, we're breaking it off here, that's going to leave us with essentially this right here, right? This is our synthon, and here's this piece, right? Here's this one that we obviously add our magnesium and halide to, right? So with this one, we would look at it and see like, okay, there's a pair of lone electrons not that far away, but there's a pair of lone electrons and there's an anion. So most likely what's going to happen is these are going to create this bond here, right? And then what ends up happening is obviously then this is the one that carries the charge, right? Because we have 1, 2, 3, 4, 5. Wait, why do they have that plus sign there? That's only 5. That's not. Oh yeah, 5. Yeah. Sorry, I'm doing my math backwards. Yeah, so then we would have that there, right? And that's where that would carry, and that's why we would end up dumping off the hydrogen. Oh, here it is. Yeah, that's why we would end up dumping off the hydrogen, because oxygen doesn't like to be positive. So yeah, if you have an anion, that's usually going to correct itself, especially if it's but you just want to look at like where your electrons have the possibility of moving to. Like these, to be honest, in this case, right, this isn't here, but this is here, so these ones won't actually go down here because this is an sp3 hybridized, so it can't send anything off over there. I didn't realize that. I didn't see the hydrogen at first. I wasn't even thinking about that. But yeah, so for this case, just like before, we actually have a hydrogen here. So this carbon already has 4 bonds. So it's not going to do that. And so the only way to correct itself here is to make a bond here. I didn't even notice the H at first.
yeah.
Right? And that's why in the end, when we want to bottle something, so they say, right, we add our Grignard. In this case, we're using bromide, and then we kick off our hydrogen. Yeah. This is your acid workup step. Just, to neutralize your atom. Let me see. This is esters. I'm trying to see if there's one that has, if you have a specific, oh, do any of these? No. Are any of these similar to what you're talking about? No, because you said alkenes, right? This is the only thing that I see with an alkene, but if you also have a homework problem, I'm happy to do that. Or is it this one? No.
Yeah,
Yes.
could we go over example 3?
Yeah, this one? Mm-hmm.
Yeah.
Yeah,
For the,
so yeah,
like
go ahead.
oxygen on wrong carbon, like for the top section, like why that's wrong.
Yeah, for sure. Okay, so so in this case, let me see. So oxygen is on, this is going, oh, okay. Okay, I see what they're saying here. Oh, this is like, okay. Sorry, I didn't have any context, so I wasn't sure what we were doing. Okay, so this is asking basically like, are you gonna turn this, oops, where's my pen? They want to know like how you're going to get from here to here, right? And so if you look at this, in this case, right, if you were to turn this into your Grignard, right, we pop the magnesium in here. If you were to choose this as your first reaction, you would end up having your magnesium bromide here on this carbon. So remember, again, this is a lot about like counting your carbons, right? So we have carbon, I'm going to start this actually over here. Okay, so we have carbon 1, 2, 3, and 4. Okay, and then now we're going to come back over here to do carbon 1, 2, 3, and 4. So now what we've done is we added oxygen to carbon 4, and we've also added 5, 6, plus 2 carbons. And we could also say 2 carbon 4, right? Does that make sense so far?
Yeah.
Okay, so that means that if we were to do, so we want to know, how do we add an oxygen here plus 2 more carbon chains, right? So if we chose this way, we chose to make the Grignard, what would happen is we would have our Grignard here, and then when we reacted it with, because remember we need to add 2 more carbons, right? So 1 and 2, right? So if we chose to do it here, what would end up happening is you would have your oxygen would be connected to, let's see, let me get this called. So 1, 2, 3, 4, 5, 6. So oxygen would be added to carbon 5 in this case, because remember that we have to have, I'm going to do this correct this time. This is going to react with our partial positive charge, because remember this has this partial negative charge. So it's going to react here rather than here, right? So that's how we end up with this oxygen on the 5th carbon, because this bond is being made between these 2 carbons over here, right?
Yeah.
So that's why we would do an SN2 reaction, turn this into an alcohol, right? So that's what we do right here. We turn this into an alcohol. And then we oxidize the reaction. So we create more bonds to oxygen and turn this into an aldehyde. And then with that, because we have this partial negative, partial positive, and then over here we have this partial positive, partial negative, now we can make this bond here. So now we've added 1, 2 carbons, and we have oxygen on 1, 2, 3, 4, our 4th carbon. And so that's how we end up with, well, you do your acid workup step first, right? And so we turn this oxygen, because we've made this bond here, these electrons have gotten kicked up. So then you have to do this, right? You don't have to do the mechanisms of this, which is nice. You can just literally like 1 and 2, and then you can just assume it to be an alcohol, right? And then again, add the PCC to do more oxidation. And so then we make more bonds to oxygen, kick off this hydrogen, and that's how we get our ketone on the 4th carbon, right? So synthesis reactions, the biggest thing is just to remember, like my biggest suggestion for sure is to count your carbons. Count your carbons, count your carbons, count your carbons. And then
Okay.
make your decision on that.
Perfect. Thank you.
Yeah, no problem. No problem. And you're also gonna see that like there's multiple ways to do these reactions, you know, so there won't necessarily always be like one right way, which is helpful. You can definitely be creative with it. But just make sure that you're following the rules, right? You're following the rules of like sp2, sp3, and you know, whichever reaction goes, like where the actual mechanisms would happen. So yeah. So what else? Let me see, these are nucleophilic addition reactions. This is, yeah. This is where you get to make, I mean, the Grignard reagent is really helpful. You know, it's a very simple way to make carbon-carbon bonds. And it's actually kind of fun to do in the lab too. So it is helpful. But definitely don't sleep on practicing your mechanisms and your reactions, because that for sure is it's never going to stop. It's going to keep building and keep building. So it's definitely good to get this stuff under your belt. Synthesis, I hated synthesis, I'm going to be honest. It was not my favorite. But it's so necessary. So what else? Jackie, I know you have questions. It's
Yeah,
Lesha,
honestly,
right?
no, honestly, I'm good with like just like listening to other people was helpful.
Okay.
So that's okay.
Okay. Lesha,
I
how are you
think-
feeling? Oh, go ahead. Sorry.
No, yeah, go ahead. No, it's fine.
I'm feeling good. Honestly, after the first exam, I feel like my understanding is getting a lot better from then to now.
Mm.
Can we go over, I guess, for another thing would just be like when it's written out in the like CH2, CH3 form rather than a line form, like
Yeah.
can kind of be confusing when it comes to creating synthons for them just because there's so many of the
Just
same
make your line
groups.
angle. I know, just make your line
Yeah.
angle. Don't even bother. Nobody can do that. Like if they can, they're lying to you. They can't do that.
Yeah. It was in that homework and I was like, this is absurd. Like there's just
Yeah.
same thing.
Yeah. And you know, Dr. Pillai says the same thing. She's like, you know, like I can, Liz, for example, right? She's like, I can't even do that in my head. So just draw it out, you know? So in this case, I mean, the reason why we do a lot of this stuff is because see this CH2 times 8, you know? So, but you have CH3 and then you have what, 1, 2, 3, 4, 5, 6, 7, 8, plus one more CH2 OH. Oh my gosh, is that correct? One. This is going to be a double bond. Whoops. So CH3 and then 1, 2, 3, 4, 5, 6, 7, 8. And then we have one more CH2 with an OH. Oh. There we go. I'm like, because I was thinking it was an aldehyde. There we go. Okay. Like this. Sorry. This and then this.
So instead of like trying to like figure that out, just convert it into a bond line and then go from there.
Yes,
Okay.
yes. Do yourself all the favors. Yes, totally. Yeah. Yeah, because this one you can see it turns into, you just end up getting a carboxylic acid. That's what ends up happening. So you get all this and then you get on the end here. Carbon. There. Yes. Yeah, just turn it into a line angle structure.
Okay, and then one last thing. Sometimes when we're going through the retrosynthesis and we're creating an ester, I think is what it's called, with like the
Mhm.
hydrogen, the double bond, and then the 2 hydrogens coming out at the
Mhm.
bottom. Sometimes when I was like going through the homework that would include a hydrogen on the end of it, and then sometimes it wouldn't. Does that implied hydrogen matter? Like, should I be
Yes.
focused like keeping those
So-
implied, but not to keep them implied?
No. It does matter. This is an aldehyde. This is an aldehyde. This is an ester.
Okay.
Do you see the difference?
Yeah.
So an aldehyde is going to be at the end. Well, not necessarily at the end, but you are going, yeah, it's going to be at the end. An aldehyde is going to be at the end. Your ketone doesn't have to be at the end, but your aldehyde is going to be at the end, and you do have to draw the hydrogen on there because it is a part of the functional group. Something that you guys covered back in OChem 1.
Yeah.
So yeah, and remember that this R right here, all that just means is your, you know, just another carbon chain. There's more hydrocarbons connected to it for however many infinite amounts, right?
Yeah.
So
Okay, so if I'm adding it to the end of a chain, I'm gonna use the H, and then if I'm like throwing it into the middle of a chain, I'm just gonna use the
yeah, it
OR.
would be a ketone. Yeah,
Okay.
yep. Yeah, well, not OR, because if you like say this, well, because see, this actually does make a ketone. So, but you end up having ones that you end up, I mean, an aldehyde, this one in particular. But yes, if you like, you're not going to add an OR to it. Your OR, like your OR, your O hydrocarbon chain, whatever that is what gets bumped off. See how it gets bumped off here? So it's kind of, it's gone. It's implied somewhere else. It's like, you know, it's over here, right? Whatever that R is.
Yeah.
So in this case, your is an oxidation reaction. I mean, sorry, reduction reaction. Yeah, oxidative reduction. Yeah, because you're adding hydrogen to it, right? You're taking away the bonds from the oxygen. Because here, this carbon had 3 bonds to oxygen, and now this carbon only has 2 bonds to oxygen.
Yeah. Okay.
Yeah. Yep. And then some of your like you have some that will take it all the way to the ketone, some that will, you know, or go from ketone to all the way to the aldehyde. And so there's those as well. Let me see the Grignard and the SN2. Yes. Oh, this is some of the stuff that we just did that one. Yeah, okay. With your retrosynthesis, yeah. What else? Ask away, Jackie. I know you want to. Yeah, excess. Yeah, make sure that if you, that's something like to remember, that if you want it to do multiple reactions, to write excess. Otherwise, if you just do one, it's kind of just implied as one. And so that's something to consider. Think about. Even here with this epoxide, again, remember you got your 1, 2, 3, and it's on the second carbon. I mean, yeah. And so here's your 1, 2, 3, right? With your epoxides. This one you've got one here, so that's going to be this bond here to here. And that's how you end up with your basically your alcohol in the end there. It's like this with your phenyl group, right? This is just to create your Grignard, whatever that is, you know. So, and then once you have that, that kind of reacts with whatever it is that you want in order to create your synthesize your new product. Let's see. What else? Talk to me. What do you want? Let me see. I'm just looking at these. Yeah. Here's an example of where it would turn into, right? Like you would end up having that double bond, but that's because the anion or the cation, excuse me, is directly connected to,
Yeah.
you know, so it's filling in that space there. It's filling in that need, so to speak.
I don't really have any other questions. That was all I had. So
Sure, yeah, no problem. Yeah. Jackie, you got anything you want to ask?
No, honestly, I think I just need to like watch videos.
Yeah, just do practicing. I remember you guys don't have to do the tosylate. There's a couple of them that you guys don't have to worry about.
Yeah, no, I saw that. I just like,
Okay.
yeah. Honestly, I'm like behind. So yeah, so I think I just like
Exams on
I just like
Friday.
need to actually like go through them. But it was
Yeah.
helpful listening to everyone else. Like you get stuff out of just like, hearing other people's questions. So that was
Yeah,
good.
for sure. For sure. Yeah, just practice your sentences. So here's like an Esther, Lesha, just so you can see that like in, where, and you would end up breaking it here, right? Just so you can see what that looks like without like it saying OR. But yeah, just you guys just keep practicing the problems. Like I said, today's Wednesday. So Sunday, I will make my notes for next week's material. I can like go over whatever, and what I'll start doing is Wednesday nights, I will use last semester or whatever, the old review notes to go over with you guys. For what is this? You guys are in week 2 right now, so starting for week 3, right?
yeah.
Okay. Yeah, so starting for week 3. So starting next Wednesday nights, I'll do like the Pillai reviews of just like and I'll just, I'll upload the PDFs and we'll just go through them one at a time. So
Yeah, thanks for asking her for those because that's going to be
Yeah.
super helpful to everybody. Because they were
Yeah.
so good last semester or like last session or whatever.
I know. Yeah, they are really helpful. I agree. We're trying to see what else we can, what else I can muster up to get to help out. So, yeah. So next week I just have to double check because y'all have different. I know that I think but see, y'all stuff is combined into 6 weeks and mine was 7.5. So I just need to make sure that the reviews are going to line up. So I'll just have to double check all that stuff. So, but I'll go through those and see. Yeah, because we had the Grignard reagent was in week 3 for us, module 3 for us, and you guys are covering that right now. So I'll have to look to
Can
make
you
sure.
like upload these summaries of the reactions? Because we had those last time and that was like really helpful for me and I can't seem to find them. Right.
Yes. Are you talking about these?
Yeah, just like the last pages of like the lecture sheet things.
Yes. Do you have the gap notes? Because they're in your gap notes as well.
So I don't now because I dropped last spring and I don't know, honestly, they were like half filled out and I was gonna get them again, but then I didn't know we weren't gonna have the reviews.
No, but for in your gap notes for this session, Do you have the gap notes for this session? Because
No, I didn't buy, because I bought them last time on like, they mailed like a book thing.
Yes. Oh, you didn't keep your book?
No, yeah, it was like, because I wanted to start fresh and then I like didn't end up doing it. And I was like, well, we're just gonna do the reviews anyways. So I didn't, and then when it started and we didn't have the reviews, I just haven't ordered it because I don't know. Like I was like, it's probably not gonna be here in time anyways.
Yeah, there's also, I think, I will, but I'm just
Thank you, yeah.
giving you, there's also a PDF version of it, so you could get it
Oh, yeah, that'd be
instantly.
cool. Yeah, okay.
So I think, let
It was
me
like
just-
$20 though. I was like trying not to buy it just for like these last pages because I know they were in them before. Like they would just
Yeah.
upload
How
them.
are you doing your notes now? Like, are you just like writing, or like, how's
I'm
that?
just like writing stuff. Honestly, I'm like
Right.
using Chad reviews because I don't think that
Yeah.
her lectures are helpful at all.
Yeah.
She doesn't really explain things. She just kind of does a example and she's like a little bit hard to understand sometimes. So it's
Mhm.
been on YouTube. And so I've been writing
Yeah.
stuff down and just trying to go through the homework while I'm doing it. Which is why I was really hoping that she would do a review that's like kind of similar to Polai's thing, where like
Yeah.
you kind of went over questions on the exam. Because there's so
Yeah.
much content that's not even on the exam, you know, so it's like I don't know.
I know. I feel for you guys. I really do. I know that especially with this, it's like, and you're like learning the same material, that it can be really challenging to like try to be learning the same stuff, but in a completely different way, especially because it's so crammed and there is a lot. Yeah, go ahead.
I feel like she's not teaching the course, like she's kind of just like leaving it on your shoulders, which is not fair
Mm.
to you. And yeah, and then we pay a lot for ASU for